Okay, hello again. A rare double filming day for me. So I think early today I filmed the last video and got a chunk of refactoring done. I'm hoping to get this next chunk of refactoring around the image layout transition stuff done. Because I think the current way I've got it working is all a bit messy and a bit copy-pasty. And it's one of those Vulkan structs that has a lot of arguments in it. Where really, for what we're doing, we only care about a small subset of them. So maybe I pay now for my sticking to that kind of one-dimensional programming idea of just write literally the dumbest thing possible to make the thing work. But I don't know. Vulkan's complicated, so I don't want to think too much about like writing code at the same time as I was thinking about how their thing all fits together. And now we think about how we write the code. So I don't think that's the end of the world. I was also having a little think, because I think I realised, ooh, where would it be? I guess if I go to create, there we go, create texture image. I think we might be being slightly naive in some of this. Yeah, in here. We create a image, and we've selected tiling optimal instead of tiling linear. I think the difference between those two is a tiling linear, if I've understood the docs right, I've quickly skimmed it, is linear basically means what you expect, right? So the memory layout is just like RGB, 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 whereas tiling optimal is implementation dependent and sort of opaque to the host machine, right? It doesn't mean anything outside of the Vulkan instance, which doesn't make any sense if we're later on down here just copying our data over to it, right? So I did... Is it cheating? I guess I cheated slightly. I went and had a look at my old Bracky platformer project to see what I'd done in there when I was following the tutorial. And it makes sense, is I create a staging buffer and then transfer the data from the host into the staging buffer in host visible, host coherent memory, and then do another transfer, this time with a Vulkan command, to then move from there to a image with optimal tiling in device local memory. So I think I'm going to put a to-do in here. I can't remember if I mentioned, but I know as I was writing this initially, I did think, I remember there is a thing about host visible memory and device local memory, and you would prefer to have these things in device local memory because it would be better for performance. I kind of think what we're writing is so simple, I'd let that be an issue until it became an issue, if that makes sense. But I think that this tiling thing is then an issue. I did have a quick look as well to see, so if I do, one fix would obviously be to come in here and just say, make that linear. But the Vulkan spec doesn't require devices to support very much stuff for linear. Basically, the linear tiling option exists really as a way to do that copying between things. So I guess instead of a staging buffer, you could have like a staging image that is linear and then copy to another one that's optimal. But all a long way of saying, I think there's a bit of thinking to do here. So that probably is a to-do for after we do this bit of refactoring. What do I want to say? I want to say copy image data to staging buffer, then transfer that data to device local memory with optimal tiling. How many to-dos do I have now? That's a question. Just that one. Okay, that's not too bad. But before we come and look at that to do, In fact, I might go stick that quickly in the README so I don't forget as well. So in here, copy image data to staging buffer, then copy, then transfer to device local image. Right. But the actual thing I was thinking is that I kind of want to go through and have a bit of a think about these. Because these memory barriers, I think there's 2 in the code so far. There's, and I think it's all around the images on the swap chain. So we're acquiring this. I can't remember if it's a GLFW thing. Or if it can't be, can it? There's somewhere where we call some like Chronos extension function to get the swap chain images. They aren't given to us in a defined format, so we have to have something like this that says take an undefined layout image and turn it into a color attachment optimal image. And then actually almost everything else in here is the same every time, right? So we're going to have an image memory barrier. If we talk about images, they're always color attachments unless we get into doing more complicated things. We only have the one Q family index that we're using, so they're always the same. So the image will be different. The old and new layouts will be different. For what we're currently doing, I think this is all the same, right? And so if I go look for the next place where we do a transition, is right after. Come on, pipeline. Do these have the place that they get done in them as well? Command pipeline barrier. So this is the bit that says where it happens. So this one happens at the bottom of the pipe. And this one up here happens at color attachment output. Sorry. Oh. So I think, what do I think? It might be useful to make a little function to generate these, because I think these are always going to be very samey. What's the best way to do this then? Let's go. I guess this goes in VK Mine. It's not a wrapper around existing logic. It's some logic I think I'm going to be doing a bunch of. Zoom you out a little bit. Zoom you out a little bit. So, what do I want to call this? I guess create image memory barrier. Why am I doing this? Because I think that the images that I'm making for the textures, I'm going to have to do some transitions on. So I guess what we're going to end up with is something that we make in an undefined format. We transition it to be a transfer destination, do the transfer, transition it to be a sampleable read-only thing. So we're going to be doing more of these, not less. So create image memory barrier might actually not take anything Vulkan specific in, as in no device or physical device, just skimming down it. So I think what we're going to have is old layout, new layout. And what is the type of those? Are image layouts. And we're going to have it return an image memory barrier. Old layout, new layout. I guess we have to pass it in the Q family index, which is a U32. So let me just say like that. Right. And user can just return struct with s-type equals image. Damn it. Image, memory, barrier. This is an image, memory, barrier. And I guess we'll add arguments if these ever come up, but let's just assume they won't until now. Well, until they do even. Old layout. New layout. The source Q index will be Q. Goodness gracious, Q family index. If we go in here, we can say the destination family index is that one as well. We need an image. Which will be a v image. So image is image. Then sub-resource range. So I think for our current really simple cases, they're all the same. So let's just hard code it. Image sub resource range. In here we'll have aspect mask is color. Base MIP level is 0. Oopsie daisy. Level count is not 0, it's 1. Base array. What's the matter with this? Aspect mask equals. There we go. 0 and layer. Right. So if we now come across to here, we can go memory barrier to present will be equal to vk create memory barrier. What are we passing in? Old layout. New layout. Old layout, new layout, Q, family index. And the image is the interesting one, renderer swap chain. Images for swap chain. Drag them back. I think it means we get rid of all this. Because we know we basically do the same thing every time. Forgot that I'd done a different one of these before. So Odin. We first off actually need to change its directory because our compilations are assumed to be from the root. Odin run main. Okay, so it's not broken. And then it does the command pipeline barrier. We might want to similarly refactor out, but let's do this one step at a time. So this one up here, Going to be a memory barrier to write. Will be defined as vk create image memory barrier. Oopsie daisy. These brackets. Old layout is undefined. New layout is color. Color attachment optimal. Renderer Q family index and renderer swap chain images at swap chain image index. Bin all of this off. And happily, that also works. Okay, so that feels a good start. Bunch of stuff untracked. What are you? BK Odin. Doesn't look like it has anything in it. That's our new function. Okay. Oh, it just got reformatted, did it? Yeah, fair enough. Okay. And what did I do in the readme? I added another thing. Okay. So we did a refactor, create image barrier for format transitions, or I said layout transitions. Is the right wording? Right. These command pipeline barriers, are they samey enough to be worth doing something similar for? So they have a stage mask, which in these are always the same. I wonder if that's reasonable. I don't know what dependency flag by region is doing. Curious, actually. What is that doing? So what would this come under? Command pipeline barrier. Can I do a search just for that? If I say command pipeline barrier. So where am I looking here? So applications have control over which layout each image sub-resource uses and can transition image sub-resource from one to another. Transitions can happen with an image memory barrier, included as part of a pipeline barrier, or a command wait events command buffer command. What is that? To wait for one or more events to enter the signal state on a device. So it takes barriers, stage masks, BK event, bit mask of pipeline stage flags. No, where's events? P events are pointed to an array of an event object handles to wait on. Is that interesting? I don't know if that is interesting. What does this do? So VK command wait events largely similar to version 2, but can only wait on signal operations defined by command set event. When it's submitted to a queue, it defines a memory dependency between prior event signal operations on the same queue or the host and subsequent commands. It must not be used to wait on event signal operations occurring on other queues. Okay, I don't know. This is what we did this time, is a command pipeline barrier. What actually is a command pipeline barrier? When it's submitted to a queue, it defines a memory dependency between commands that were submitted to the same queues before it and those submitted to the same queue after it. So yeah, you kind of you guarantee this thing will happen after some set of events and before some other set of events, and that's why it has that those stage masks. If it was recorded outside a render pass instance, the first synchronization scope includes all commands that occur earlier in submission order. If it was recorded inside a render pass, the first synchronization scope includes only commands that occur early in submission order. In either case, the first synchronization scope is limited to operations on the pipeline stages determined by the source stage mask. That's a point, actually. What are my stage masks if I'm... What's this here? Source stages. It jumped us 2 down here. If a synchronization command includes a source stage mask, its first synchronization scope only includes execution of the pipeline stages specified in that mask, and any logically earlier stages, its first access scope only includes memory accesses performed by pipeline stages explicitly specified in the source stage mask. If a synchronization command includes a destination stage mask, only includes execution of the pipeline stages specified in that mask, and any logically... What if I'm not in a pipeline, though? Did you do this one? Stage none. Top of pipe. What's a point? Do I have to be inside of a graphics pipeline or some other pipeline? So I have a command buffer. Do I just have no flags in that case? Dependency flags. Memory barriers. So you'd have a memory barrier. Yeah, so I guess I was like image memory barriers. If it was recorded outside a render pass instance, the first synchronization scope includes all commands that occur earlier in submission order. Frame buffer space pipeline stages is frame buffer local, otherwise it is frame buffer global. I can't lie, I didn't understand any of that. So, what do we do? I think we just write one without worrying about all of that. Try and get this one working, and then we'll look back and see if we want to do anything else. Okay. So I'm going to call that refactoring step done. Which is to say this one here. So image layout transitions, we're pulled into a thing. We're going to worry about the memory barriers later. Let's close this thing and go look at our renderer again. So, where are we up to if that's what we're doing then? Can I say create image? Nope. Oh my god, what have I done? Okay, discard that. Stage that. Call this to do done. Right. Let's go and find our to-do again. There we go. So, I do think this is an issue, and I think it's something we have to do right away. I think it also makes life more complicated than it sounds, because we've now got to create a staging buffer, which isn't too bad, but we're also going to need to create a command pool. Oh, I guess we've got a command pool already, have we? Yeah. Is it a bad idea to just use the one we've already got? Reset command buffer. Level primaries. We might be able to just use that one. Because we're going to have to be able to record a transfer command to move from the buffer to the image. And I think our memory barriers are going to be recorded in there as well, because those command memory barriers. Yeah, so we're going to have to create our image, do a memory barrier to make it a transfer destination, do the transfer, do another memory barrier. Let me scribble that. So, what actually is the plan? Is up in here. That's going to annoy me. Okay, let's just put them there. What are we doing? I just said all of that, so we're going to need to create a staging buffer. We're going to need to map its memory, copy image data to it. Then we're going to need to create a texture image with memory. Then, oops, allocated and bound. Then, grab a tea. Create the texture image with its memory allocated and bound. Why am I blanking? Transition image layout to transfer destination. Then do transfer command. And then transition the image layout to sample read only, I think it's called, or sample read optimal. Yeah, something like that. I think that's our big blob of to do. So, all of this is basically wrong, is what that means, I think. It's an interesting point as well. Does that mean we're going to need a version of this that doesn't map the memory? Is that easy to do? Can I just say in here, allocate resource memory will be a procedure. So I'm assuming it's a bad idea to map memory, which would give us a pointer that refers to the memory on the GPU when that memory is going to be device local, so it's not accessible from the host. I don't know if that blows up when you request it, or if that's something that will just give you undefined behavior, but it seems worth avoiding. So let's go ahead and do our resource. Device is a device. And physical device is physical device. Hoping we can basically write this once and use it in both of these functions. You're going to return OK ball, memory, the device memory, and no raw pointer. So I think it's going to be all of this and this, but not that. If we just yoink all this, put it in there, and then down here, we're going to go ahead and say, okay, memory is equal to allocate resource memory for resource and device and physical device. If not okay, we just return, because okay is passed through. It's going to need a happy return, which will just look like that. So we're in here, we pop that in there. I think that should work. Excellent. That seems prudent. And then, like I say, when we allocate memory for our non-host visible image, it won't be mapped, and so we avoid any headaches. Cool. Is it worth keeping all of this stuff? I'm going to say yes. Tiling optimal, show mode exclusive, initial layout is undefined, samples one. So yeah, that's not changed. This is though, so that doesn't exist anymore. And we don't want that. So I think that should now work. Renderer of type renderer has no field texture image mapped memory. Yeah, because we're not doing that anymore. Grand. I'm gonna have to specify the type of memory that I want allocated. Because in here, it's currently always host visible, host coherent. Right. Let's pass that in here then. So desired memory type properties, which is going to be a v memory property flags. Bang that out of there. And it should blow up in a couple of spots. So this one will need the same change. Called desired memory type properties to pass through v memory property flags. So it can be passed into there. And compile. Got more wrong. Because you, sir, now need this. This one is the one that we don't actually want to be that. So it's going to be host visible. And I think that's all that one needs to be. This one is the one that's going to have our host coherent and the other thing. So we can go ahead and do that in there. And I think, actually, we're going to want that again. So let's copy that. And paste it in here, because this one's our index buffer. Do you compile? Yes. Right. You can see the kind of Russian nesting dolls of like little complex layers that we're sort of unfolding, but you can definitely be too dramatic. This isn't that bad. The other good news, I don't think this chunk here needs to be particularly fast because we're just going to do it once on load. Well, that's an interesting point. I guess, so in the future we're going to end up with multiple textures and potentially a lot of textures to load. So it would definitely be faster to batch them. I think I'm going to write it in a way that makes it easy to just do them all one at a time, and then we'll worry about batching them if, you know, load time's painful or something. So where are we actually up into there then? So that one is done. So let's start at the top. How do we create a staging buffer? I guess we go and copy what we do down here. All this stuff. So let me go ahead and say here, that's my buffer create info. Which is a buffer create info. Have we read in the image at this point? We have. So I guess actually what we want here will be size of data 0 times data. Usage, is it called transfer source? Sharing mode exclusive. Yeah. We create a buffer. Let me put it at the top here. So we're going to have a staging buffer, which is a Vulkan dot. It's going to be local to this block. It only needs to live as long as this little chunk here. Right, that's not too painful. So staging buffer, buffer create info. We go transfer source. If we do all of that, and then we write that to staging buffer. And if it fails, then fatal failed to create texture image staging buffer. So if we're up there, keeping track, we've got to that point. We now want to do our VK allocate and map resource memory for our staging buffer, our renderer device, our renderer physical device, and host coherent host visible. I think what we want, hit the wrong buttons. Yeah, it's host visible and host coherent. Should probably look up what host coherent actually means again. I don't remember. I think host visible is obvious. It means that my CPU based program has access to the memory of the GPU. I think host coherent is like a synchronizing thing, but I can't remember for sure. So that probably is worth looking up at some point. Your return type is all of that. So let's yoink it. And we'll go ahead and do this. Can I then reformat, or is it not? No, it doesn't recognize that. I guess you're not allowed to do that over multiple lines. Oh, the types don't make sense if you do this. Cool. So let's go ahead and do that. It's not happy with OK. Is that what it's saying? OK is redeclared and res is redeclared. Bugger. So that's buffer create res and image create res. And then you, sir, care about buffer create res, and you care about buffer create res. It's going to be buffer create, okay. Down here is image create res, and image create res, and image allocate, okay. What have we messed up? Is it spelling? Is undefined. Oh, I hate this. And then you can't do that. What a pain. Right. Can we put them back to just being okay and okay? So what's okay, not okay? Because it gets defined somewhere else first, I guess. It's up here. Yeah. Annoying. Okay. Make you whatever I made you. You're a bool, so if not buffer create. Create's the wrong word, isn't it? Buffer allocate. Then VK fatal. You failed to allocate. Texture, image, staging, buffer, memory. Cool. So we've done that one now. It's just for sanity's sake. Yep, compiles, no warnings. I'm surprised by no warnings. Shouldn't this staging buffer complain? Because it still exists. Like we don't ever free the memory or unmap it. So I think this should all get a defer to tidy it up. It should be Vulkan. Is it destroy? Buffer, staging, buffer. What's the matter with you? It takes a renderer device. There we go. Vulkan dot unmap memory. Make that nil. What's your problem? Like that. And Vulkan free that memory. I think you do that. That seems prudent, right? Only exists for this block. If you're trying to use it outside of that block, something's gone horribly wrong. We want to do that copy, which again I think I can steal from down here. So let's yoink that. Come back up to here. So we're doing a non-overlapping copy into, I've just called it memory mapped so far, haven't I? It doesn't live on renderer because it's just local. Of raw data vertices is not what I want, it's raw data data. And I've already had to do that once, so let's go ahead and do something up here to say like image data size. I'll call it data there, so let's say data size, and that's going to be size of data 0 in bytes, which is size of data 0 times len data. And then we do that in here. That's, oh, well, I'll just call it data size in bytes. Can I just bin that off and give it the right type up here? Should be Vulkan.device size. We'll take a cast to Vulkan device size, which now makes that look dumb. So let's do that. So data size in bytes. And then down here we have raw data and data size in bytes. That shouldn't blow up. Cool. So we've copied image data across. Transition image layout to transfer destination. Do the transfer command. Which actually I think in here means we need to do something like begin recording commands to command buffer. And then down here, end recording commands to command buffer and submit. Oh. Does that sound right? I think it does. Alright, I'm going to do a little work in progress because I think we've kind of done our like CPU side logic is how I'm thinking of this, right? We've done all the stuff to get everything off the CPU and onto the GPU. Now we've got the awkward bit of shuffling stuff around in the GPU, which I may very well make a mess of. So work in progress towards texture image sampling. Have a quick sip of my drink. So at this point we already have a command buffer. I don't think there's any reason to not just use it. Right? We need some way to wait as well, aren't we? Right, because you can submit the job, but you don't necessarily know that you're actually done. Oh, so we're gonna need like a semaphore or something, or do we just do a device wait idle? I think we put a device wait idle in there. So device. Because just because you've submitted the work doesn't mean the work's done, does it? That's the point. So I think we do need to do something to say like submit the job and then actually wait for it to finish. Oh, okay. How do we begin recording commands? Oh, hey, look at me. Begin info. Command buffer begin, one time submit. Is it worth pulling that out into a function? Maybe. Right, let's see. If we go to VK, in fact, let's put it into another window. VK, again, I'm going to call this mine. This isn't like just wrapping a bit of functionality, it's a specific use case, right? I want to say in here, begin one time submit command. Which will be a proc that takes a command buffer and nothing else. So that's going to take command, a buffer, which will be a Vulkan command, buffer, and it will return I'm going to just do an OK ball. I guess we just copy that. So that is command buffer begin info. S type is equal to command begin info, and flags, we are going to pass it this one-time submit thing. This is where you can record your command buffer and then use it over and over, and that might be a performance thing to improve, but again, we're not that at that point yet. Hopefully we never are, right? Hopefully the whole thing just works super buttery smooth, because it's not a complicated game we're building, and life is super simple. It's not our renderer, because it's just a command buffer. How about that? And then we're going to just say an if not success res k equals false else. In fact, that just seems wordy, doesn't it? We can do return true, else return false, and even that seems wordy, because actually what we're doing is we're saying return res is equal to dot success. If res is success, we get true, and then we're okay. We can check that that's all making sense if we come in here, and instead of doing that, we just do vk dot begin one time submit command. That's a rubbish name, isn't it? Begin recording one time submit commands. Into our renderer dot command buffer. We can then bang all of that away. We can say begin recording commands. In fact, we don't actually need anything else off of it, so we can just do that. And we can say if not, then we blow up. So let's test that out. Happy days. Right. Do I have any other place where I have a begin? Or if I say record with an end recording command buffer. Which you literally just call end. Yeah, there's no state associated with that one, is there? So let's just do that. Cool. And now we can do our begin recording. So past all of this, down here, and we're going to go VK, begin recording, one time submit commands. Going to use our renderer dot command buffer. I'm going to say if not that, then VK fatal failed to begin recording. So it's texture image commands. I suppose we should do our end as well while we're here, right? So if I can end command buffer. Yeah, there we go. Yeah, you just call end command buffer with the command buffer. Oh, damn it. Have I lost where I was? Go ahead and call end command buffer. For renderer command buffer. And we'll go ahead and say if that is not equal to success, then we VK fatal to end recording texture image commands. So commands go here, and submission goes here. Because yeah, if I jump down to, oops, if I make a type. End command buffer. You then have to do the submit business. Submit info, command buffer count. Signals to let it know that it's done. Queue present. How do you know if it's actually done though? This is all in our draw frame stuff, this one, isn't it? Yeah, you can see at the top, can't you? Right. It's just me. Does it feel like we're making progress in every little step, and then I stop and take a look back, and I'm like, my god, we've done nothing. Okay. So, what are we recording in here then? I might move these to do comments into those spots just to make them easier. So, that is done. That is done. So, the to-dos are that wants to go in there. Like so. And that wants to go in there. And then it's done. So we are getting somewhere. We can bang out all this to do. And we'll... Do you know what? Because I keep searching for to-dos to know where I'm going to next. Let's just pop to-do and to-do. Transition image layout to transfer destination. VK create image memory barrier. Old layout, new layout. So old layout will be undefined. New layout will be transfer destination. Renderer Q family index. And our image. Have I just call it image? No, it's going to be on our renderer texture image. Nice. That returns me an image barrier. So what are you? This is our transfer destination barrier. And then down here, we're going to have a transfer. Oh no, it's going to be a... I'm not even sure what it's going to be called, but create image memory barrier from transfer destination optimal to I think it's shader read only. Renderer Q family index. Renderer dot texture image. So this it's not transfer anything. This one is our shader read only barrier, like that. Okay. What do we need still, though? We still need to actually use those barriers. So when we are down here, we make the barrier. You still have to do this command like this. So let's not worry about reuse. Not yet, at least. We grab that. And we... Wow, can't find... There we go. Each one of these then needs one of these things. Can these be empty? Image memory barrier count. User RR transfer destination barrier. Do the transfer, and then we're going to want something very similar to that. Which I'll put in here. Say source stage mask, desk stage mask, dependency flags. This one, I've put it in the wrong place, haven't I? Shader read only barrier. That will go in there. Let's see. Yeah, it's not happy. Damn it. Source stage mask must not be 0 unless synchronization 2 is enabled. If the synchronization 2 feature is not enabled, it must not be 0. Damn it. Does that mean maybe top a pipe to be like... We want to make sure these things happen like right at the start of the pipeline. New layout is not compatible with image usage flag, image usage sampled bit. Source queue, family index, desk queue, family index, define a family queue. Ownership transfer or old layout and new layout, define an image layout transition. Or new layout is that, then image must have been created with VK image usage transfer bit. Oh, so I'm meant to have created it with a thing on it. Where's my image creation? Under usage, yeah, you're not sampled. Color, depth, fragment, host transfer. Maybe I should have read that a bit closer. Oh no, there's more. So you are going to be a transfer destination. Read only optimal. Requires the sampled bit. So we're in here and we're going to have to say sampled. Excellent. Yeah, makes sense. It's going to be a place we transfer data to, and it's a place that's going to have stuff sampled. Cool. So, all that's left then, we need to do a transfer. I don't know if we've done a data transfer command yet, so I might have to look that up. I might just go quickly grab our submit commands. Oops, submit commands, stuffed from down here. Again, I think this is all simple enough to just yoink. To'd. Oops, to do. Bang you into there. And then, yeah, I think we just have to do await idle, right? Which I think is Vulkan device wait idle. Okay, that's why it should be like, I would like us to wait until absolutely everything is done. It's the dumbest form of synchronizing, right? That's a point. I'm expecting none of these. So that should be nil. No complaints. So yeah, it's just our do transfer command that's left in to do. Right, how do you do a transfer command? Is there anything in here that's just like commands? Resource creation, shader interfaces, image operations, clear commands, copy commands, copy between buffers and images. Enable applications to load and store data between images and application to find offsets in memory buffer. When copying between a buffer and an image, texels in the image and bytes in the buffer are accessed as follows. X, Y, Z. Rotation addressing. Alright, there's a lot of data, or a lot of information there. Let's just really hope this is easy. So we have a command buffer, source buffer, destination image layout. What is region count? Number of regions to copy, pointer regions to pointer to an array of VK buffer image copy structures specifying the regions to copy. Huh? Buffer offset, buffer row length, buffer image height. sub-resource layers. Oh my goodness, what is all this? Okay. I'll tell you what, let's pull that over to here. And you fit width. So we're in here. Void, so it can't fail. Command, copy, buffer to image. You say it like that, it sounds so simple. Renderer dot command buffer. Our source buffer is called staging buffer. And our destination image is renderer dot texture image. Destination image layout. At this point, we've done this. Create an image memory barrier. Is this an image layout? Why can't it find that? Yeah, their image layout. So it's a transfer dest optimal. Found nothing. Very unhappy. Command, copy, buffer to image. It's because I'm looking in the wrong place, aren't I? Vulkan, do that. And then you, sir, can be a transfer dest optimal. Alright. Transfer dest optimal, region count. Let me try making it 0. And it complains. Region count must be greater than 0. Yeah, it makes sense, doesn't it? Because it's got all the information about. I don't know what's got information about. It's got information about something. You take a reference to a thing. So let's say in here, this is our buffer image copy, which is a VK buffer image copy with a load of stuff in it, and then you're gonna point at it. And again, sorry, Vulkan.buffer image copy, because it's not from my thing. Then we would like to go. Now maybe it's worth reading this. Each source region specified by P regions is copied from the source buffer to the destination region of the destination image. If any of the specified regions overlaps in memory with any of the specified regions in the image, that sounds a weird thing to do though. If any region accesses a depth aspect in that, we won't be. Okay. That makes sense, right? What they're saying is this buffer contains image data, but we don't know if it's the whole image or if it's just chunks of the image. So we need to do something to tell it actually what we wanted to do, and what we wanted to do is all of this. Image sub-resource layers is all that mip-map stuff that we're not actually using yet. Okay. Let's just try filling this in. So, no S-type. Interesting. Buffer offset is 0. Buffer row length and buffer image height specifying texels as sub-region. Larger 2 or 3 dimensional image. Either of these values is 0. It's considered tightly packed, so I'm going to just try setting them to 0. Oops, make U 0. Make U 0. Then image sub resource. I don't know what to do with yet. Aspect mask. Color. Base array layer count. MIP level. Where's the other image sub-resources we've had? This definitely isn't the first one. Oh, maybe it is. If we're going to look for aspect masks. Oops. Can I take that stuff out of there? And can we do that? Nope. Maybe? Alright, let's see how that goes. Image extent we are going to have to work out, and it's going to be a VK extent 3D with depth equals 1. Width is X in scope. What's the matter with you? Extent 3D, same thing. Cannot assign of type I32. We need to cast them to U32s. And image offset 0. Can I convert untyped value 0 to an offset 3D? I'm gonna go ahead and guess they're all 0, but we'll see what that does. So buffer image copy. Copy the buffer to the image. Right. Let's see, does that blow up? I mean, there's no complaint. Right, it just worked. Let's get rid of that again. So, what does that do? Create the texture image resource. We load an PNG. We make a temporary buffer. We actually make it. We allocate memory for it. We map that memory. Copy data across and into it. We create our image. What is this? Renderer dot texture image memory. Allocate resource memory to make our host visible memory, which is not mapped because it's oh, all right. Texture image memory. That should say device local, shouldn't it? Let's just check that still compiles. It does. We begin recording a command. We define. Well, we don't define anything. What is this? We begin recording a command. We do the pipeline barrier to transition our image into the right layout, which is transfer destination optimal. We copy our buffer data to the image. Then we transition the image to read-only optimal. We end the command buffer. We submit the command. Or we submit the command buffer. And then we do a dumb wait. We stop the world because we only do this once on load, so it's not the end of the world if it's slow. Right. Well, that might have worked. There's kind of no knowing at this point. I'm going to try running it into RenderDoc. I've got a feeling RenderDoc won't show anything because it's not hooked into the graphics pipeline. Was that a big enough change that it's worth us going through this a little bit? Data size bytes is all this guff. I mean, am I even reading it? I can't be bothered. Let's just go ahead. Commit. This is still work in progress. Work towards texture sampling. Where are we up to then? Because I think this might be the last thing we do today. We now have a image created with data transferred into it. Cool. I'm gonna push that up. And then let's go and make ourselves a quick test. If we go to Flectris, if we do an Odin build with a debug build, we'll just check that is git ignored. We will first check it runs main.bin, and it does, and it resizes, and we'll run RenderDoc, and we'll go and see if we launch main.bin. It does launch. We'll capture a frame. I've got a feeling though, if we go look in our resource inspector, we only have an image view for the swap chain image. There's a bunch of swap chain images. But yeah, this looks like... it looks like it only sees stuff. Baked command buffer. Hang on, let me just do a search image. Yeah. I mean, actually, yeah, to be fair, even if you could see things that aren't to do with the graphics pipeline directly, because I've captured the frame, like, this stuff all happened before a frame, right? So I don't know how RenderDoc could even show it to you. Unless there's a tool or a window that I don't know about in here somewhere, but extensions, window, texture viewer, Python, event browser. Event browser? It's you over here. Yeah, so you can see it's starting at the start of a frame. Yeah, okay. I think we will get to see it in RenderDoc, but only when we're a bit further along. Basically, by the time we can see it in RenderDoc, we'll be actually supposedly doing the sampling. So I don't think we're ever actually going to see anything useful about this in RenderDoc. So let's trust our guts. We think we're there. To actually change this plan slightly, right? Because maybe once it's bound into the graphics pipeline, we might be able to see it in RenderDoc. We're going to bind it to the graphics pipeline in a combined sampler. Alright, so RenderDoc. Let's do that as and when it seems useful, but let's plan to create the image view. Create combined image sampler. Bind it to the graphics pipeline. Use it in our fragment shader, I think. Bada bing, bada boom. I think that's us done. And then that should be that one ticked off. But as always, small step. Update readme. It's 9:30 now. Have I got a reasonable chance? See, I think the next step gets us into all of the descriptor layout stuff that we've managed to duck so far. Or actually, potentially, that world might be different now because of the dynamic rendering stuff. If I go and look for the word descriptor. Oops. Where's my graphics pipeline? There we go. We create the graphics pipeline somewhere in here. Okay, yeah. It's done in a function. Can I do a compile grep rn graphics pipeline? So that's where it gets defined on the thing. Gets created. Pipeline equals. What is this? Vulkan bind the pipeline so it exists at the point that we're doing our rendering. Yeah, I might have to go have a read. I'm so just unsure about what I'd even be looking for. Yeah, I think we get nowhere. Only thing I can think of. Is it a thing that gets passed in potentially to here? There's a bunch of stuff about these. Is there anything in this about descriptor sets? Dynamic state, base pipeline, subpass, render pass. Did it used to live in render pass? Is it one of those? Okay, that another opaque handle. Yeah, I don't remember. I don't remember anywhere near well enough, so that's one we can discover next time. But I've got work tomorrow, and I don't think I'm going to get far enough with this next chunk before it's too late. So that is it for today. How long were we going there? About an hour and a half. I mean, we did a thing. We don't know if it worked, but we did it. And it compiles. So should we just see it run again just to confirm in our brain? Don't save in that file, please. Grand. Let's close all of that and call it a night. So if anybody in the world makes it this far, I hope you've enjoyed. Maybe you've learned something. Maybe we're just having time. And I'll hopefully catch you on the next one.